So this question is a question, it's about a carbonate of metal M. So we don't know what the metal M is. We know it's a metal and we know it's in the compound M2CO3 and we're expected to work out what M is. And the way this question works is it guides us through all the different steps and makes it quite easy for us. But in some ways it makes the understanding of it more difficult, and I suspect with the new type of spec questions they probably wouldn't ask you, give you all these steps. They just go straight to just 6 marks, what is M. So we're going to do it that way because it's actually easier to sort of explain the understanding behind that. So first pause the video, have a go at it yourself, and now I'm going to adjust the question. So we're just going to do this version, so we're not going to follow the steps, we're just going to go, so imagine if it said 6 marks, work out M. Right, first off, so let's highlight and annotate and try and understand what the question is asking us. It's talking about carbonate, talking about M in here. It's a carbonate. You know, or you should know, that a carbonate is CO3 2 minus. It's got 2 minus charge. We know that M is a metal. There's 2 of them, so it tells us what the charge on this has got to be. It's got to be 1 plus. So we know it's 1 plus, which suggests it's probably a group 1 metal. So it could be maybe lithium, sodium, potassium, something like that. Okay. If you don't understand why it has to be 1 plus, you might want to go look back some earlier videos at sort of making compounds and how to sort of work out what the formula of a compound is. That's sort of key basic knowledge, and if you haven't got that, there's no point moving on until you're really confident with that. As I mentioned before, it's best to start backwards with what they actually want. So you want to work out the thing of M, what M actually is. To work out M, you need to know its relative atomic mass. To work out a relative atomic mass of something, you have to know the total molecular mass of the whole thing. So if you knew the whole thing of this was 100, and you know what carbon is, you know carbon's 12, you know oxygen's 16 times 3, so you can then work out what M is. Let's write an equation for that. So the MR of M2 equals the MR of the whole thing, so whatever the MR of the whole thing is, minus the MR of the CO3. And we know some of that information already. So we know carbon's 12, we know oxygen's 16, what's that, 48. So we know this whole thing here is 16, so that's, 60. 12 plus 16 plus 16 plus 16, so 60. So all that allows us to work out, if we know the MR of the whole thing, we can then work out the MR of M2. And then to work out the MR of M, so the AR of M even, not the MR, the AR of M is going to be the MR of M2 divided by 2. So whatever this comes out as, divided by 2, and it'll give us the AR of M. And then we can use the AR and the periodic table to work out what M actually is and to answer the question. So as we can see, our first job is to work out the MR of M2CO3. So let's think, what's the only equation you know that has MR in it? Let's write that down. So the MR of M2CO3 equals the mass of it divided by the moles. So let's think about what we already have. Do we have the mass? Yes, we've got the total mass. Let's put that in. So looking at the question again, you can see that the sample of mass 0.394. So we've got the total mass, so we can put it into there. So all we need to do now is we need to work out the moles. So you can see we've got the mass, we just need the moles of M2CO3. Right, so how can we work out the moles of M2CO3? Well, they haven't given us any information that allows us to do that. Often I've seen students trying to calculate the moles, so rearranging this question, but you can't do that without this equation, without the MR. So we need to work out the moles another way. Well, you can work out moles another way by using molar ratios. If we know the moles of this, or this, or this, or this, if we know the moles of anything else in the equation, we can use ratios to work out the moles that we got of the thing that we want. So we want to work out the moles of this, and we're given information, if you see, required the addition of 21.7 cm cubed of 0.263 mole per dm cube solution of hydrochloric acid. So it's given us information of how much acid, HCl, it took to neutralize that. So if we know the volume and the concentration of this, we can use that to work out the moles, and then we can use the ratios to work out the moles of this. So let's write down the equation for the ratio. So we can see that the moles of this, let's highlight that second, so the moles of this in blue equals the moles of this highlighted in green, okay, there's the moles of that, divided by 2 molar ratios. So now what we've got to do is work out the moles of this and then divide it by 2, and we put it back in the other equation. So let's do that. So we've got moles of the HCl equals the concentration times the volume. Let's plug in the number. So we can see the concentration times the volume. Obviously divide the volume by 1,000 because that's in cm cubed. We want it in dm cubed. That equals 0.005707. So now we can take this mole of HCl and put it into the equation over here. Let's first just make this all small. So we take that number there, the moles of HCl, divide it by 2 to give us the moles of this. Okay, and that gives us 0.002853. You might notice actually if you're looking at the mark scheme for this question, in the mark scheme it gives it as 0.00283, so it only goes to 3 significant figures. AQA is a bit random about its approach to significant figures. It doesn't really follow the set rules, but it sort of skips between, so sometimes it gives the answer to 4, sometimes to 3. Basically, they'll always credit the marks if you give to more sig figs rather than less, unless the question says give your answer to the appropriate significant figures. A good general rule just to follow to get good marks in AQA questions, just do your working to 1 more sig fig than the final answer is going to be. So my final answer is going to be to 3 sig figs, that's sort of the bare minimum for most AQA questions, so my working is going to be to 4. AQA questions always allow for students, they allow sort of a range of answers. So if you have left in the whole sort of number that was in the calculator, you will still get the marks. Anyway, we've got the moles of the M2CO3 now, so let's put that moles into this equation over here and work out the MR of M2CO3. So I'm just placing that number in here, that's the moles, and now we can do the math and work out the MR. So that comes out to 138. So this is our total MR, so now we can put it into this yellow equation to work out the MR of just the M2, because we know the MR of the CO3. So you can see I've just put it in here, 138.1 minus 60, and that equals 78.1. So 78.1, so we put this into this equation over here, let's use green, so 78.1, so that's the MR of M2, but we want the AR of just M, so let's divide that by 2. So divide that by 2. So dividing that by 2 gives us 39, and this is our final answer, so I'm going to go to 1 sig fig. It's actually 39.05, but I'm going to round that to 39.1 to 1 sig fig, and that's our relative atomic mass. So that's the answer to this bit here. Okay, and then we use the periodic table. We look what element has close to this relative atomic mass. It might not be exactly the same, because remember this is an experiment, okay, and the periodic table is really accurate experiments. So, but whatever thing is close to that, and the thing which is close to it is potassium. So we look at it, that must be potassium. I just realised why my student found this difficult. The student who asked me to do this question, I think there's a mistake in the mark scheme, or it's missing a piece of information. So my student, they actually got 78.1 as their answer for the relative atomic mass. So they must have forgotten to divide by 2, because remember there's 2 M's, not just 1 M. So when they worked out this 78.1, or I've lost it there, when they worked out the answer to this one, they must have thought that was the final answer, but they forgot they must divide that by 2. But the mark scheme says, consequently, if a student thinks that's the AR, they can still gain what's called a consequential mark. So it means that you still get the mark even though you made a mistake, but they'd lose the mark for relative atomic mass, but they gain the mark for the identity of M if they just looked at what element has a relative atomic mass of around 78.1. So I think the answer to that was, let's have a look. Yeah, so the answer to that was selenium. Now obviously it can't be selenium. Selenium would be very unlikely to form this compound, but they would still gain a consequential mark, which just shows you that even if you get a question wrong, just keep going, even if it's not making sense, because you can still gain consequential marks. If you ever seen the words consequential, that's what that means then. Okay, yeah, so answer potassium, I think that's everything, fantastic.